7.4 is about similarity in right triangles. In this problem here, this is problem 2, finding the geometric means. You're just setting up proportions. Okay, so you're talking about 6 equals over 15. So notice how they're across from each other. That's the geometric mean. So all we do is put x and x across from each other here. Okay, x times x is x squared. 6 times 15 is 90. Take the square root of both sides. X equals the square root of 90. Now let's break down 90. Again, a little refresher on reducing radicals. What perfect square goes into 90? If I take about my perfect squares, it's 10 squared means hundreds of perfect squares. Actually, it goes 12 squared, which means 144. 11 squared, which is 121. 10 squared, which is 100. 9 squared, which is 81. 8 squared, which is 64. 7 squared is 49. 6 squared is 36. 5 squared is 25, 4 squared is 16, 3 squared is 9, 2 squared is 4, start over here, and 1 squared is 1. So these are all my perfect squares. What's the biggest perfect square that goes into 90? Now, this one's pretty easy, but if it were me, I'd start at 81 and just start dividing. 9 divided by 81, 90 divided by 64, 90 divided by 49, and work your way down. But in this case, of course, you can see that the 9 would go into it. This breaks up into the square root of 9 times 10. And when you have the multiplication of numbers underneath a radical, you can break that up into the square root of 9 times the square root of 10. Why did I do that? Because the square root of 9 is 3, and I get the square root of 10. Correlated 1 talks about the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the length of the segments of the hypotenuse. A lot of wordage. But all you can do is take, and when you have the altitude, okay, you set it up as geometric mean to the segments of the hypotenuse. So in this case, because 4 is your altitude, see how 4 is your geometric mean? It equals, set it up across from each other, and then you put the other two parts of the hypotenuse there. If it's a leg, okay, see how 2 is a leg here? Okay, you're going to set it up as the geometric mean of the part of the hypotenuse closest to it. So that's the 1 over the length of the whole hypotenuse, which is the 4. So we'll talk about that a little bit more in our problems as we go here. In problem 3, what are the values of x and y? Well, it doesn't really matter how you start this particular problem, but let's do the y first because it's the altitude. So to solve for the y, let's set it up as the geometric mean. Doesn't really matter how you start it out with. Okay? So what are my two parts of my hypotenuse? Well, y is my geometric mean. My hypotenuse is across from and we're talking of the big right triangle. So the two parts are 4 and 12. Cross multiply, I get y squared equals 48. Square root both sides, I get y equals the square root of 48. Break that down. Again, it happens that 16 goes into it. Y equals the square root of 16 times the square root of 3, and that ends up giving me 4 radical 3. Okay, now let's talk about x. X being the side. Again, it's a leg, so we're good. Set it up as a geometric mean. So x over equals over x. So it's the geometric mean. Make sure it's across from each other. The leg closest to it, or that part of the hypotenuse closest to it, which is 4, over the length of the whole hypotenuse, which is 12 plus 4, which is 16. You can do the same thing. Cross multiply, get x squared equals 64. Square root both sides. This one kind of works out nice. X equals 8. Now again, just my little reminder of algebra, it should be plus or minus 8, and this should be plus or minus 4 radical 3, but because it's a triangle and we're talking about real values, we're only going to use the positive end of it. Problem 4 is set up a little bit differently. We're still solving for x here, but I understand that when we're doing this, x is part of my hypotenuse, so I can't use that as my geometric mean. What do I have? Well, I've got that 20 sitting there, which is my leg. So let's do that. 20 is my geometric mean. Okay, so 20 equals over 20. So you set it up just like that. What's the part of the hypotenuse closest to that leg, which is x, and then the whole hypotenuse, which is x plus 9. Okay, again, cross multiply. You get 20 times 20, which is 400, equals, and then you get x times x plus 9. Now, what do I do here? Distribute through again. 400 equals x squared plus 9x. Subtract the 400. I get 0 equals x squared plus 9x minus 400. Now, there's a couple different ways you could solve this. Personally, the easiest way is probably to do the quadratic formula, okay, because it works every time. I don't have to worry about factoring and doing it. If you want to factor, go ahead. I would use the quadratic formula, which in this case, negative b plus or minus square root b squared minus 4 times a times c all over 2a. Little throwback to algebra. And remember, what's in front of the x squared is the a, in front of the x is the b, and then the last part is the c. So negative b plus or minus the square root of b squared minus 4 times a times c, which is negative 400, all over 2 times a. Well, again, I would just straight punch all that in my calculator. I get negative 9 plus or minus the square root of, my bad, I forgot to hit record. When you punch on your calculator, you get 1,681 all over 2. Again, take the square root of that. That's going to give me negative 9 plus or minus 41 over 2. Now let's break this up into two problems. Negative 9 plus 41 over 2 and negative 9 minus 41 over 2. Go ahead and solve. Again, you can punch in your calculator. Negative 9 plus 41 divided by 2 is going to give me 16. And then negative 9 minus 41 divided by 2 gives me negative 25. Now, when I look at these two answers, what is the only one I can have as part of a triangle here? Again, negative 25 is not going to work, so my only answer here would be 16.